Hello and welcome to the MecSoft demonstration series, where you can see live demonstrations for real users and real-world applications. For more information about our products or to schedule your own live demonstration, just give us a call or visit us at www.mecsoft.com. Without further delay, we invite you to sit back and enjoy the demonstration.
So what I currently have here is a prismatic part. So in a case of a prismatic part, we could detect different types of features. It could be features like pockets, holes, planar faces. So features can be identified and detected from solid geometries, even as well as mesh geometries. And once the features have been generated, you could program toolpaths from those identified features. So the first step in detecting features in the mill module is to have the machining objects browser loaded. So if you go to your machining browser in your mill module and you click on tools and machining objects, you will notice that the machining objects browser typically is displayed either below the machining browser, or it could be displayed over on to the side in here. Now if your machining objects browser is not visible, you'd want to click on Tools and Machining Objects to toggle the display of the Machining Objects browser. Now, on the Machining Objects browser, you'd want to go over to the tab called Features. Now, this option is available in Standard, Expert, Pro, and Premium configurations of our mill module. Now, under the Features tab, you'd want to select Create Machining Features. You are now being prompted to select a face, and in this particular part I'm going to just pick the top face on the part and press right click or right mouse button click or enter to accept your selections. Now you'll notice that the features that have been identified are displayed under the Features tab for the orientation we've selected, so you can identify features from multiple orientations as well, and we'll get to that momentarily. Now, for the face that we selected in here, you'll notice that there's a planar face that's been identified, and it's highlighted on the part. And we have pockets. We have two prismatic pockets. You can see that there's an open pocket and a closed pocket. So open pocket where one of the sides is open, so there's three walls to it and one of the sides is open. And we've also identified two different hole features in here on the part. So once you have these features identified, you could program toolpaths from these identified features. So I'm going to go back and display the milling browser in here. And you can go to this Features tab and you can select the operation that you like to program. So I'm going to highlight prismatic pockets in here and right mouse button click, and I'm going to choose pocketing. Now you'll notice that as I chose pocketing, it identified an open and a closed pocket. So to program open pockets, you would have to use a facing operation. So the open pockets will be ignored when you program a pocketing operation. So only the closed pocket is automatically selected. So you make your selection for the tool in here, and then specify, you can set in all your cutting parameters and computes the toolpath based on the feature that you selected. So you'll notice that all your depth and all the parameters are automatically derived or obtained from the feature. So this saves you the time of having to go back and input all the parameters like your cut depth and all the parameters. Now we programmed the feature toolpath for the closed pocket. Now to program the feature for the open pocket in here, I'm going to highlight the first feature, which is Prismatic Pocket Feature 1, right click and then choose Facing. And the feature is automatically selected. I have a tool selected in here, and I'm just going to go through the process of just specifying my depth per cut and then generate. You'll now notice that the open pocket is programmed using a facing operation. So as you can tell, the cutter enters into the pocket from the outside of the material. Now once you have these open pockets and the closed pockets programmed, I could program the hole features in here. So I could select the hole feature, right mouse button click, and I could choose from the available operation types or hole machining. So I'm going to pick drilling, and you'll see that the parameters, the whole cross section is being displayed under the hole feature tree, and it also displays the total depth and the diameter of the feature that's identified. You can make a selection for your tool, specify the parameters, generate, and you can repeat the same step for the other hole feature. Now the hole features were identified as two separate hole features, as the holes are different depths. Even though the diameter could be the same, the depths are different in here, so that's why you see two different hole features being identified in here. So we now programmed the toolpaths after identifying the features from one of the orientations. Now let's go ahead and run a verification of this in here. So I'm going to go ahead and switch over to the Simulate tab, and then select the setup, and then hit play, and that shows you the cut material simulation and verification of the features being programmed. Now if you'd like to go back and add an additional operation, so let's say you would want to go ahead and do a profile to finish the material that's being left on this closed pocket, you can go back to this Features tab, select the feature, right-click, and add an additional operation. Now depending on the feature that's been identified, the available operation types are automatically determined for you. So I've now added a profile operation to go ahead and finish the pocket to the size of the pocket. So I'm going to select play, and there's the simulation after the profile operation has been programmed. Now let's go back and take a look at how we can detect and identify features from additional sites or orientation. Now the part that we're looking at in here, as you can tell, there are some additional features. You have a counter bore on the bottom side of the part, and you also have an additional hole on the side of this part. So you could go back into the Features tab and click on Create Machining Features, and just pick the face from the bottom, right click or press enter to accept it, and you'll now notice that there's a new orientation that's added in here, and it basically displays your features that's identified. So you have a planar face, and you have two hole features in here for each of the orientations that you pick. Now I can also go to pick the hole feature from the face over here. So go back and click on Create Machining Feature, select the face, right click. So create machining feature, pick a face, right click to accept it. So there is an orientation for planar face number 3. Orientation 3 shows planar face feature and a hole feature in here. So to program these additional orientations, you can insert a new setup in here to establish the orientation, or you can just select the whole feature, you can right click and choose the machining operation, and the additional setup will automatically be inserted under the current setup. So I'm now going to take a look at the cross section in here. You can see that this is a counter bore, so I would like to use a hole profiling operation to program this, and I'm going to restrict the toolpath to profile out the larger diameter on the counter bore in here, and I'm going to select Create Hole Feature Mopset. Now since the through hole is already being programmed from the orientation, I can exclude that from being drilled from the bottom side. You'll now notice that a new setup has been inserted, and the whole feature operation has been derived in here, created. So you can make a change or selection of your tool as needed, and then pick Generate to process the toolpath. So the whole feature operation has been created to program the counter bore. Similarly, you can go back and program the whole feature from the side number 3, which is orientation 3. Right click on it, and I'm going to choose to drill the hole, and I can specify a tool for it. I'm going to use a drill bit, generate the toolpath, and then I can go back and also finish this by programming a hole profiling operation using a 1/4 inch end mill and generate. So you'll now notice that the toolpaths have been programmed in here, and let's go ahead and run a verification. So simulate. You're able to see the simulation from multiple orientations, and we're going to simulate it from the orientation 3, where the hole number 3 is also being drilled. Now, to get more information on how we can program from additional orientations or additional setups, you can always reach out to us, and we can let you know what configuration you would be requiring to be able to program from additional orientations of our mill module. So this basically gives you a overview of how to detect different types of features in here. In this particular case, we've detected closed pockets, open pockets, holes, and counterboards, and also from different orientations, as you noticed it.